So, selamat sejahtera kepada doktor. So, we are from group Java Coffee and today we are going to present our assignment 2. So, this is our GitHub repository. So, I just introduce myself first. So, my name is Jun Wei. My matric number is 2931142. So, this is my team members. Okay. So, for our title is real-time messaging with Apache Kafka in Craft mode. So, I just proceed to the project overview first. Okay, so this project we develop a real-time data streaming system integrating Apache Kafka with the YouTube data API, and we use Docker for a scalable deployment. So for the objective is we want to create a reliable system to collect and process YouTube video metadata in real time using Kafka producer consumers data. So for the methodology that we use is two Java-based application, a Kafka producer and consumer that are containerized with Docker. So for the producer, it will fetch metadata from the YouTube data API and sends it to a Kafka topic. And the consumer will process it in real time. So for the Kafka broker will runs in craft mode with configurations managed via environment variables. So, and for the result is the system will successfully stream YouTube metadata with the producer sending data to the Kafka topic and the consumer will process it seamlessly. Okay, so as a conclusion is the Kafka and YouTube API integration via Docker will offers a scalable, reliable streaming solution with easy configuration and potential for expansion. So that's all for me. Thank you.
Assalamualaikum. My name is Muhammad Fakhrul Hakimy bin Faka, and today I'm going to present our assignment 2, which is the real-time messaging with Apache Kafka in Keras mode. So first of all, I'm going to show how to run the Apache Kafka in Keras mode in PC1 or as the broker. First, we need to download the Apache file and then extract it into your directory, and then open the directory. This first of all, we need to generate the UUID. We can get the UUID by running this command, and then we can copy this UUID, and we can use this command to format the storage for the Kafka logs. Paste the UUID here, and if it appears as metadata has been formatted, that means it has been created the new Kafka logs file. Kafka logs file here has been created. Then we can start the server and make sure that the server properties is correctly setting up like this. Make sure that the IP address is matched with your current PC1 IP, and run this with this command over here. Apache Kafka has been run successfully, and we can check what the topics that is available in this Kafka server. In here we can see that we got the YouTube API and the consumer offset. Now we need to run the producer using the Docker. First of all, we can pull the Docker using this command. Copy this and paste it to pull the latest Docker image in the Docker Hub. And then we can run it using this Docker run in interactive, and then see got the automatically remove the Docker once it stopped. The bootstrap server, which is the IP for the broker, and the YouTube API key over here. Copy this and run, and we can try and send the first message here using test, and you can see here that the message has been successfully sent. We can check it on our second PC over here. The Docker is run like this, and then we can pull it like before, which is using the Docker pull, but This time we select as consumer over here. Paste the command docker pull, and then we need to wait for the pulling because it's the first time we making a pulling from the docker hub. While waiting for the PC2 to pull the image, we can move to the PC3. For PC3, we're going run the consumer in the consumer file. Similar to the PC 1 and 2, we need to make sure that it's connected to the same network, which is this network. And then we can test the consumer by running this in the IntelliJ IDE. This is the consumer when it's run. This is our first message that we sent before. Now I'm going to send another message in the PC1, which is message 123, and then it already be sent to this consumer. We can make a searching channel for the name by using search slash Mr. Beast, for example. We can see in the first PC1, it going to display everything, and then we're going to receive it in the consumer over here. We receive total of 50 search, which is the maximum search possible, has been set in the our YouTube API method. And then below it, it's going to show the highest subscriber and the highest video count. Uh, that's all for the PC3. Okay, the pulling is done. We can run the consumer the same way we run the producer before on PC1. We just paste it and then enter. It's going to receive all the message that we just sent on the PC1. We can see here, this is the searching for the Mr. Beast. We can send another message from the PC1, which is we search for the slash search. We search for PewDiePie, and then PC1 going to make the searching and then going to send to the consumer. Here we already received the second search, which is the PewDiePie channel. It lists total of 50 search over here, and then displaying every channel that it's found. And here the highest subscriber and the highest video count. That's all from me. Thank you.
Hi, my name is Zun Hom, engine number 92508. Today, I'm presenting a Kafka-based architecture that enables real-time streaming of YouTube videos metadata across multiple machines. Our system begins with the YouTube Data API, which provides live video metadata such video titles, description, publish times, and channel information. This metadata is ingested by a Kafka producer, which is containerized using Docker. The producer runs on PC1, continuously fetching data from the API and sending it to Apache Kafka, which also runs on PC1. We are using Apache Kafka in craft mode, which eliminates the needs for Zookeeper and simplifies the setup. Kafka serves as the central machine broker, efficiently handling the data stream. From Kafka, the processed data is distributed to three Kafka consumers: PC2, running on separate machines, PC2, PC3, and PC4, all of which are also containerized. These consumers subscribe to Kafka topics and process the data in parallel, ensuring scalability and load distribution. The final processed information is sent to the output layer, which displays the channel information. In summary, this architecture supports real-time distributed metadata processing using Docker containers and Kafka powerful PaaS model, all coordinated across multiple PC. And that's all from me. Thank you.
Hello and good day. My name is Muazzam Ester and my metric number is 293153. Now I will show the result from my real-time messaging system using Apache Kafka in craft mode with the YouTube Data API. As you can see, the first screenshot is producer send a message, which is this is the Kafka producer. It is running and ready to send message. I type the message testing, and it was sent to the Kafka topic. The red text is just a warning about logging and does not affect how the system works. And then the second screenshot is about consumer received the message. Here is the Kafka consumer. It received the message testing correctly. This shows the connection between the producer, Kafka, and consumer is working fine. And then third screenshot is about search on YouTube using command search CoffeeZilla. I type the command search CoffeeZilla, and then this tell the producer to connect the YouTube API and find channel related to the CoffeeZilla. The producer send this data to the Kafka, and then we go to the fourth screenshot. The consumer receives YouTube data. Now the consumer shows the YouTube channel data. It prints the channel name, number of subscriber, total videos, thumbnail URL, and YouTube URL. This proves that our system can get live data from YouTube and show it in real time. And the last one is uh, highest subscriber and video count. The output show it show the system also check which channel has the most subscribers and which one has the most video. In this test, CoffeeZilla has both the highest subscriber count and the most videos. This shows that our consumer can also produce the data. Okay, to sum up, the producer can send normal message or search YouTube. And then Kafka transfer the message quickly. And then the consumer receive and show the data in real time. The system can also find useful information like the top channel. This means the project works and can be used for real-time data streaming.
My name is Sophia Binti Ihsan. I am going to wrap up our presentation. So let's quickly go over what we have built. The main goal of our project was to stream YouTube video data in real time. To do that, we use a combination of Apache Kafka, Docker, and the YouTube data API. We designed a simple but effective architecture with a producer fetching video information from YouTube, sending it to Kafka, and a consumer receiving and displaying that data. Everything ran inside Docker containers, which made it easier for the team to run and test the system consistently on different machines. In the end, the system successfully streamed live video metadata, proving that our setup works. This project also helped us learn a lot. First, we saw how powerful Kafka can be for handling real-time data. Even with something simple like YouTube video info, the speed and flexibility were impressive. Second, Docker was a big help. We didn't have to waste time fixing environment issues. It made collaboration much more easier. Third, using the YouTube API taught us how to bring external data into our own system, a key skill for real-world projects. That's all from me. Thank you.